done so, you need to really, today would be a great time to do it. You need to go and set up and join our WebAssign portal. So I'll show you what that looks like. If you go into Canvas and you go to how to enroll in WebAssign, it will take you through the steps. So you click on that. And the thing that you want to notice is this fella here, our class key, right? That's what this is called, is different from another thing, which I wish they had a better name, called the class code. The class key is what's important for you right now, and that's this guy here. So you click on WebAssign login page, like that. And it takes you to here, right? And then you go to students and you go down to, I have a class key. And then you put in that class key, which is this one, and you hit enroll. And do you see it's me? And whoa, did I give the wrong class key? Man, the wrong bloody class? That would be really bad of me. Let me check. Where the heck am I? That particular one was 146. I do not want 146. That was bad news. So I probably clicked on the wrong one. So apologize for that. Am I in 146 here? Can't really tell. Oh, I have given the wrong class key. That is did anybody else notice that I gave the wrong class key here? Because I bet you I gave the correct class key. See it? Darn it in space.
Mine worked.
Yeah, mine worked as well.
Let me check that again.
Yeah, mine was fine.
I wonder if that was just me not copying that key correctly. God, right. So you hit in WebAssign, you go to students, I have a class key, you click on that, and it better have the numbers I just saw, right, and enroll. Hey, I don't know what happened there. I copied the same key, but now it works. You see it's 142 our class? Now, if you continue, I'm not going to, because that would mean I join my own class, and that would be a pain in the butt to undo. You click on that, and that's you now in the class. And in there, you will see all the good stuff. So let me show you kind of what you would see by doing it this way. Once you've joined up, you would see something that would look like that. Now, you've got 2 weeks of free grace where you don't need to fork out money. But at the end of that 2 weeks, you've got to pay for it. If you use the class code, not the class key, the class code is like you could go to Olympic College and they'll give you one. It's a bit like, you know, the cards that you swipe and you get a number, and that's the number you type in, and that's you paid for it. Or you can go to their site and just use a credit card and pay for it. But you have to pay eventually. And once you do, you're done. So can you see here's the radian stuff, the arc length, and the right angle triangle. Did that make sense, Caitlin? I know I made a little hiccup because I somehow screwed up in the copy.
Yes, thank you.
Right, and Canvas is obvious. Canvas is special, right? So let's get started. First thing, piece of information. I'm going to have to finish this class just a little bit early because my dog Bailey needs to go to the hospital. He's not been too well for the last few days, and we're kind of worried about him. So I've got an appointment at 2:30, but I have to get there. So I'll probably be leaving around about 10 to. Okay, so that is almost certainly going to mean that I won't get finished all the work from 6-2. So when you go and do your homework from 6-2, I'm going to amend it. I'm going to take out all the stuff that you haven't covered, and I'll add that to next week's homework, right? So that'll just make it okay. And the other thing is that the test, you know, the online test, it will appear Saturday morning. You can do it anytime Saturday or Sunday you like, but the minute you click on it, I think I've said this a few times, you've got 90 minutes to finish. And I'll make sure that the test only covers stuff up to what we get to today.
How long is it? Like how many questions?
It's 90 minutes, which is probably 30 minutes more than you need. I don't know how many questions it is because I haven't written it yet. You know, off the top of my head, 10 questions, but it might be a little bit more, a little bit less. They'll be pretty much identical to the homework questions. That's where I'm going to get them from.
So, if you don't mind me interrupting real fast.
Right. Yeah.
I have a homework problem that I was just doing, and it wasn't giving me a whole number. I like triple checked it, but it wouldn't take any of the answers I gave. I tried rounding whole number, I tried doing full decimals. I'm just worried that that's something like that's going to be on the test, and I'm misunderstanding something.
I hear your worries. I have an office hour at 10 o'clock on Friday. Why don't you drop in then and we can spend plenty of time on it and
Right.
sort it out. That goes for everyone. Just because I don't get you on Friday, office hour is still Friday at 10 and the link to it is in Canvas, so you can use that. Okay, so 6-2, right angle triangles is basically what it is about, and we're going to focus today on the 6 trig ratios of a right angle triangle. And to do that, we need to know this. How do you name the 3 sides of a right angle triangle? The 3 sides are called opposite, adjacent, and hypotenuse. And you have a right angle triangle, and let's imagine that you have an angle of interest. In other words, one of those 2 angles, that one or this one, will be the angle of interest. That's going to be the one that you're going to use to name the 3 sides. The side that's furthest away, right, this side down here, the one that's opposite the angle is called opposite. The one next to it or adjacent to it is called the adjacent. And this, the longest of the 3, right, the one that's furthest away from the right angle, this one has always been called the hypotenuse, right? And the reason that you need to know the 3 names of a triangle is because to get these 6 trig ratios, we're going to use a combination of 2 out of the 3. Now, let's orientate it in a funny angle like this. There's my right angle. And let's put theta here. And I'll call this guy A, I'll call this guy B, and I'll call this guy C. And they're actually homework questions, not unlike this. Which one of those is the opposite?
A.
Agreed? I'll do OPP for short now. Which one of them's the hypotenuse?
B.
B.
Agreed. And so obviously that one's adjacent. Do you feel comfortable that if I gave you a right angle triangle, no matter how it was turned, no matter how it was orientated, if I gave you a right angle triangle and I gave you the angle of interest, right, the angle that's going to be used to name it, that you could decide which one of these 3 guys is the opposite, the adjacent, and then the hypotenuse? Do you feel comfortable with that? Right. So
So
it's just, yes.
if we're not given the angle, we technically can't determine if it's opposite or adjacent, correct?
Correct. So they better tell you or it's a bad question. You're right, they couldn't. Now, let's do the 6 trig ratios. I'm going to do a nice, simple orientated right angle triangle. I'll do this one. I'm going to put the angle at the bottom because I want to. So the angle of interest here, we'll call it theta. And this side here is going to be called the opposite, and we'll just use 3 letters. This side here is going to be called the adjacent, and this third side is going to be called the hypotenuse. And we now have 6 trig ratios, and here they are. The first one is called the sine. So the sine trig ratio, right, the sine of theta. You get that by having the opposite divided by the hypotenuse. The next is the cosine. And to get the cosine, it's the adjacent divided by the hypotenuse. And the third one is the tangent. And the tangent is the opposite over the adjacent. And there's a little mnemonic. A mnemonic is just a word that helps you to remember things. In this case, the mnemonic is SOHCAHTOA. Any of you remember SOHCAHTOA? You might have heard it in high school or something, right? The sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. And the tangent is opposite over adjacent. Isn't that a cool little word to help you remember all the different combinations? SOHCAHTOA. Now, I said there's 6. These are the 3 main ones, but there are 3 others. There's one called the cosecant of theta. There's one called the secant of theta. And there's one called the cotangent of theta. And the cosecant is basically the reciprocal of that one. In other words, you turn them upside down. The secant is the reciprocal of the cosine. So you turn that one upside down. And finally, the cotangent is the reciprocal of that guy. Which means that there is a connection between these two, isn't there? So the sine has like a husband and wife deal, right? Or partners. Sine has a partner. His partner is cosecant. And isn't the cosecant the reciprocal 1 over sine? And the secant is 1 over the cosine. And the cotangent is 1 over the tangent. And that is the 6 trig ratios. Okay. SOHCAHTOA helps you get the sine, cosine, tan. Don't you get the other 3 by just remembering to turn them upside down, right? To do the reciprocals. So far, so good. It's really just memory work, trying to memorize all sorts of things. Put that over there for the time being. So this is a pretty basic question, but you are asked it. So suppose I give you a right angle triangle. And I tell you that the angle of interest is up here. And not only that, you get told the lengths of the 3 sides of the right angle triangle. It's kind of nice of them. And you are being asked to find the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. In other words, find the 6 trig ratios. Step 1. First thing you should do in this type of question is name the 3 sides. Right, from this angle's, right, this is the angle of interest. What name do we give to 7?
Adjacent.
Agreed. What name do we give to the 25?
Hypotenuse.
Hypotenuse.
Agreed. Would you agree the third one has to be what's left, right? So if you know how you get 2 of them, you know how you get all of them. Well, that's step 1. Step 2 is pretty much the end of the line. Find the 6 ratios. Okay, the sine is opposite over hypotenuse, which in this case is 24 over 25. And won't the cosecant just be 25 over 24? Do you see I just turn it upside down and I get it for free? Right, the cosine is going to be the adjacent over the hypotenuse. And that's going to be 7 over 25. And so the secant, which is reciprocal of that, is going to be 25 over 7. And now the tangent is the opposite over the adjacent. Well, I forgot to write the formula, but too late now. And then the reciprocal of it. Does that look like a pretty straightforward kind of homework question, right? Here's a triangle, tell you all the numbers, we'll give you that. Find the 6 trig ratios. Great. Now I'm going to show you a homework question, which is essentially the same question, but it might look a little weird, but it's not really as weird as it looks. I don't think anyway. Do you see they've got the triangle written like this, but the numbers for what A is worth, what B is worth, and then what C is worth, do you see they're up there? Wouldn't it be nice if they just wrote them on the triangle and you wouldn't need to worry about it? That's the weird bit, okay? Based on this angle of interest, what is B?
Opposite.
And isn't its value 40? Sorry, 8. Well, let's try that a third time. 9, my side, it's not great. What would C be in this question?
Be 41.
Hypotenuse.
And won't that be 41 in this question? And won't A be the adjacent, and won't that be 40? So if someone went and said to you, find the sine of theta, won't you just say opposite over hypotenuse, right? In this case, the opposite would be B, and the hypotenuse would be C. So that would be 40 out of 41.
I think that's 9 over 41.
Is
I
it?
don't know. I actually.
Oh,
have-
you are right. You are right. God, my eyesight's getting worse. You are correct. The cosine, of course, would be 40 out of 41. If you get the first 3, don't you get the last 3 for free? Don't you just turn them upside down? So, you know, that's a quick way of doing it. Right. Now, in this question, which I'm going to have to copy down, but at least you can see it for a few moments, we have a triangle at a strange orientation. It's kind of on a bevel. There's the right angle. There's a guy over here called alpha, and then another one in the other corner called beta. And you've got a side called X, which I'm just going to put 6, and a side called Y, which I'm going to put down now as 9. And we are being asked to find, well, in question A, for instance, the sine of alpha and separately the cosine of beta. Right, so as we got the question set up. Now, what this question does is it shows you that the angle of interest does have an effect on the answer, right? It does make a difference. So if I'm going to find the sine of alpha, don't I need to name these 3 sides according to what angle alpha is? But when I want to get the cosine of beta, don't I have to name these 3 sides according to what angle B is? Won't that kind of change? So if I do a little line down here, I wouldn't suggest you do this normally, but I'm going to do it right now. From angle alpha's perspective, won't this be the hypotenuse? Won't this be the adjacent? And won't this be the opposite? Great. And this number is 6, and this number is 9. And has someone noticed something that is, I think the first time it's happened today? There's a missing side. And I need to know that side, right? Because I bet you in some of the questions, aren't I going to need to know what the adjacent is equal to? How do I do that? We're going to have to use something a Greek guy figured out. That's your clue.
I think another formula, isn't it?
Yeah.
A squared plus B squared equals C squared. I forget what it's called.
It's the right formula. It's called Pythagoras, the Greek guy.
That's right.
Now, what he discovered was that for right angle triangles, and only for right angle triangles, A, by the way, is the hypotenuse. And it's equal to the other 2 guys squared and added. Now, what that allows us to do is that if you tell me any 2 sides of a right angle triangle, can I always find the third one? Right, so 9 squared is 81. 6 squared is 36. Okay. As long as you do it to both sides, it's okay, rule. Tell me what to do to both sides here.
Subtract 36.
Okay, not trusting my brain today. 81 take away 36, I get 45. So what is C going to be? What do I do to both sides to find C?
Take the square root.
There you go. So I can go up here. I'll make it a new color just to show you that it wasn't originally in the question. Don't we now know all three sides? And so this guy here is now going to be the square root of 45. So if you're asking me to find the sine of angle alpha, it's the opposite over the hypotenuse, which in this case is just 6 over 9, which I would simplify down to 2/3. Can you imagine that later on they ask you for the cosine of alpha? Then that will be adjacent over hypotenuse, and that's going to be the square root of 45 divided by 9. I'm going to come back to that in a minute, but right now I'm leaving it like that. Now, if you are interested in angle beta, right, that's the angle of interest, there is a little bit of a change, right? The sides are not going to change how long they are, but they are going to change their names, or at least 2 of them are. Won't this one still be the hypotenuse? What will the side 6 be now called?
Adjacent.
And what will the square root of 45 then be called?
Opposite.
Opposite. And so when you are being asked, in this case, to find the cosine of beta, you're going to be saying, oh, it's adjacent over hypotenuse, 6 over 9, which happens to be 2/3. Interesting. And then you're going to, let's say, find the tan of beta. Well, won't the tan of beta be opposite divided by adjacent? And so in this case, it's square root of 45 divided by 6. Everything look good? Everything is good. Are you happy with what we did? Okay. Now, let's return to both these answers. I call this style points. That's my name for it. You should always make your answer as pretty and as simple as possible. And it's sometimes easy to overlook it, but square roots can be simplified, and therefore so can the answer because of that. I'll put it down here. If I want to simplify the square root of 45, I find 2 numbers that multiply together that are 45, but one of them has to be a square number. So in this case, 9. So 9 times 5 works, right? I can then separate them and end up with 3 square root of 5. So this guy becomes 3 square root of 5 over 9. Then I can cancel the 3's down. And that is the final answer. You see, it's a little bit simpler than it was to start with. Now, WebAssign is very hit and miss in these answers. Sometimes WebAssign will say that's correct, and other times it will say it's wrong because they want that one. So if you put in an answer into WebAssign and it says it's wrong, but you're 99% sure you did everything correctly, maybe what you didn't do was simplify it, right? So be aware that that's thing. I believe it's really good at always picking the simplified answer, right? It'll always give you that one is right if you do it. And that's a good habit to be in, right? Always think of simplifying what I call style points. Now, in the same vein, won't that guy become 3 root 5 over 6? And so that becomes what? Root 5 over 2. And that would be the best version of that one. Are we comfortable about one of these? They tell you 2 angles and ask you sine of alpha and cosine of beta and all that carry on. Are we good with that? Right. Is there any issues with that before we move on to the next piece then? You feel comfortable if I gave you a triangle, you could get the 6 trig ratios. If I gave you 2 guys and one of the sides was missing, you could still do it. Feel good with that? Right. Okay, so what is the next thing we're going to deal with? Well, we are going to use these guys to help us find missing sides and then later on missing angles. So the one I'm going to start off with is version equation 6. There's the right angle. Here is 60 degrees. This guy is called X. And this guy is 8. And the question is, find what X is, right? Well, step 1. Name the sides. Now you may say, well, where's the theta? Well, isn't 60 degrees the only guy in town? So here's your theta, right? Here's your angle of interest, 60 degrees. So based on that, won't I call this fella the opposite? And won't I call this fella the adjacent? Sorry, this fella up here, the adjacent. Got this all in time. And won't this fella be the hypotenuse? So that's step 1. Step 2. Use SOHCAHTOA to decide which of the 3 choices of trig ratios to use. Now, if you look at the question that I've just done here, I know the hypotenuse and I want to find X. So the 2 sides that are going to be important are the ones that you know and the ones you're trying to find. Now, that is opposite and hypotenuse. In SOHCAHTOA, which one of those 3 uses the opposite and the hypotenuse in it?
Sine.
So right now, I'll just keep it general. The sine of theta is the opposite of the hypotenuse. Are you happy, everybody, about how I decided using these 2 that it was the sine and not one of the other 2? It's always going to be one of these 3, right? Not the other 3. I know there's 6, but do you know those other 3? They don't get used much, right? These are the 3 bread and butter guys. These are the guys that get used really all the time. Now, in this case, isn't the angle 60 degrees? And, oh, I should tell you what I'm doing here. Step 3. Put in the numbers you know. Well, I have 60 degrees over. The opposite, I don't know what it is, but isn't it called X? And the adjacent I do know, which is that guy. Now, I'm just rewriting this again because it looks a bit crunched in me and I don't like things being crunched, right? So that's where we are right now, aren't we, in step 3? Now, step 4 is coming up. Use cross multiplication to find the unknown side X. So I'm going to rewrite this guy one more time. Right now, I know that the sine of 60 degrees is X over 8. If you call this guy sine of 60 over 1, doesn't cross multiplication. You ever seen that tricky cross multiplication, right? Boom, boom. x times 1 gets me x, and it's equal to 8 times the sine of 60 degrees. Are you with me? There we go. Now, if I go to my calculator and hit mode button and make sure that things are in degrees, because it's 60 degrees, and I hit that, second quick, I should be able to do 8 times the sine of 60. And guess what? The answer is 6.93, roughly. Now, do you notice that that answer is a decimal? And in many questions, probably all of them, that is totally fine. Now, I don't know, because I'm looking at an example of that, how many decimal places is it? Oh, okay. It said to 5 decimal places, 6 points, so redo that. 6.92820 then would be the answer to 5 decimal places. So if the question said, give me the missing side to 5 decimal places, I'd write that. If it said, I don't know, 3 decimal places, it would be that. If it said, I guess, 1 decimal place, doesn't it depend on what they ask? So make sure you read it. But sometimes it doesn't tell you. And when that happens, it's because you are being asked to find the missing x as an exact value. And you're going to say, but I don't know the exact value of 60 degrees, for instance. And that's where a little table that I'm about to give you is going to be used. So this table I'm about to write down, you're going to write it in a piece of paper and just have it handy when you need it, right? So when you get the sine of 45 or the cosine of 60, you're going to look up this table. So x is going to be the angle, right? And then it's going to be the sine of x, the cosine of x, and the tan of x, because they're the only 3 that we care about. And I'm going to put in 0, 30 degrees, 45 degrees, and finally, whoops, 60 degrees, I forgot one more, and finally 90 degrees. Now I got them all. Now, the sine of 0 degrees is 0. The cosine of 0 degrees is 1, and the tangent of 0 degrees is 0. So if you ever have to do an exact value, these are the numbers you use. Actually, the calculator would work with these, so I guess it doesn't need to be there. Now, if you're doing the sine of 30, excuse me, showing the calculator, do you see the answer's a half? The cosine is √3 upon 2. And the tangent is √3 upon 3. You just have to trust me for right now. In another section, we are going to do a thing called the unit circle, where we'll actually return back to that and show you where these come from. Now, this guy is √2/2, this guy is √2/2, and this guy is 1. If we do 60 degrees, this is √3/2, this is a half, and this guy is √3. And 90 degrees, this guy is 1, this guy is 0, and this guy doesn't even exist. So if I go back to this question, x is 8 times the sine of 60 degrees. If they don't mention decimal places, it means it has to be one of these guys, which it is. Isn't it going to be x times √3 upon 2, which gets you 4√3? Are we comfortable with some questions are not going to be decimals? They're going to be exact values. How do I tell? The question's going to say, give me the answer. or it's going to say, give me the answer in 3 decimal places. If it just says, give me the answer, you need that. If it says to 3 decimal places, you're good to go. Any questions about that? But make a copy of that somewhere, a little piece of paper, and just like have it next to you for the homework questions, right? It's going to be something that you use a lot, an awful lot. So you may want a couple of copies if you've got time. Are we good with that question? Right. Any questions? You good? Okay. Let's try our next one. I think I should do a decimal-y thing, right? Try to find a decimal thing. Oh God, there's not many, is there? Okay, I'll make up one. This is like question 7. You're given a right angle triangle, looking something like that. And this angle here is theta. A is 28, so that's 28 goes there, and X we're trying to find, and theta is actually 52 degrees. Okay. So we're being asked to find X. From this guy's perspective, won't this be the opposite? This will be the adjacent, and this will be the hypotenuse. Okay. We know that guy, which is the opposite, and we're trying to find this guy. Oh, that's boring. I wish they'd given me a better ratio, but too late now. That's the question. Which ratio uses opposite and hypotenuse?
Sine.
Sine. Wouldn't have been better if they gave us a tangent or a cosine, just to be different, but whatever. So I know that the sine of theta is opposite over hypotenuse. In this question, it becomes, oh, by the way, find X to 5 decimal places. Can you see this one then is going to be pretty much the same thing, but we don't need to worry about that table now, right? It's not going to be used. And so the sine of 52 degrees is equal to 28 over X, right? Opposite is 28, hypotenuse is X. So if I do my cross multiply, I get that. So you always end up cross multiplying. Sometimes you get lucky like the first one. What would I need to do to both sides to find X?
Divide by sine of 52 degrees.
Right. And I would typically wait, I wouldn't turn that into a decimal. I'd wait till I got there. And then I just go 28 divided by the sine of 52 and to 5 decimal places, 35.53251. Are we happy with how that question ended up? I just wish it had been a tan or something, that's all. I'm getting a good vibe of this. I think this is going well for most of you, right? There's nothing too shocking, too, what the heck are they doing? Right, now. This one is a kind of general version of the last 2 questions. We got an angle, we got a theta, they got a y, we got an x, and we got an a for no particular reason. And in this case, a is 8, so I guess I'll write that down as 8. You're going to be called the opposite, you're going to be called the adjacent, and you are going to be called the hypotenuse. And here is question A. Find X. And question B. Find out what Y is. Now you should, I hope, say, wait a minute, there's not enough information here to answer the question. Don't I need to know that angle, right? You got to tell me theta's 20 degrees, right? But they get around that because they're asking you to find X and find Y. in terms of the angle theta. So I'm going to approach the question the same way. If I wanted to find x, right, wouldn't I say, okay, I know the adjacent and I want to find x. Which trig formula uses an opposite and an adjacent in it?
Tangent.
Okay, so the tangent of theta is opposite over adjacent. In this case, it stays as a theta. Normally that would turn into a number, but not this time. And the opposite over 8. Now, if I do a quick cross multiply, oh, we got the good version, right? The easy version. Would you agree that x is just 8 tan theta then? And that's what they're asking. Find x with, in terms of theta. Couldn't you also do y the same way? If I wanted to do y, what uses an adjacent and an hypotenuse in it? Which of the trigs uses adjacent and hypotenuse?
Cosine.
Cosine. So can you imagine I'd do something like that with a little cross multiply and eventually I'd get y equals. And so if you're wondering what's happening, by the way, that's question 8. That's what's going on. Just checking the time. Yeah, I got a little bit of time left, but not much. Where am I going with this?
So I had a quick question.
Yes, tell me.
So on that cosine one, right, we're finding adjacent over hypotenuse, right?
Yes.
What I got is 8 over cosine theta.
Okay.
Right? Would you just leave it like that?
Yeah.
Right.
And when you type it into, do you know that little math thing that appears on the right hand side? If you go way down to the bottom, I think it's called symbols or something, you'll be able to find the theta button.
Yeah. Okay.
Okay. Right. The next one's a kind of cool puzzle. It puzzled me for a minute because I thought, hey, there's not enough information, but there is. You just have to think about it. Suppose I tell you tan theta is the square root of 15. And I'd like to get all the other trig ratios. Now, it looks like there's just not enough information to find out what sine theta is, cosine, and so on, but I can make it happen. Being a visual kind of person, I would draw a right angle triangle. I'd put that as theta. I'd name in the usual way the opposite, the adjacent, and the hypotenuse. And then I'd say, wait a minute, isn't the tangent opposite over adjacent? And I'd say, well, that's a bit awkward. I got a square root and a fraction. Well, how about if I call it square root of 15 over 1? Isn't that still the square root of 15? Now that I've done that, what number is the opposite?
Square root of 15.
And what number's the adjacent?
1.
Sneaky. Right? Now, can I use Pythagoras to get the third missing side? Because I'll need that as well, won't I? Anybody want to do it in their head? Because it's actually a really nice number. 1 squared plus the square root of 15 squared, right? And all the other stuff you need to do to get the answer.
16.
Square root of 16, almost. Square root of 16, it's 4.
Oh, right.
Right? Now, once you've got that guy, can't you get the sine of theta, the cosine of theta, the tan of theta, and any other trig ratio you want? Because don't you have all the sides and you're good to go? I'll just pick one at random. Suppose I wanted to get the cosecant of theta. When I just do hypotenuse divided by opposite. And the hypotenuse is 4 divided by the opposite, which is square root of 15. Are you okay with that? Style points. Do you think you're allowed to do square roots on the bottom of fractions? I mean, I know you want to leave it that way, but do you think you're allowed to leave it that way? Nah. How do we fix fractions that have square roots in the bottom? We do it by multiplying by a special version of 1. It's called rationalizing the denominator, if you want to hear its term. Would you agree that's just a very weird version of 1? Right, so I'm not changing what it looks like. But what we get now is the square root of 4 square root of 15 over 15. And that's a nicer answer because there's no fraction on the bottom. So if you get a square root of 7 in the bottom or a square root of 2 in the bottom, that's how you would fix it, right? Just multiply by root 7 over root 7 or root 2 over root 2. If you got a question, different question, but if you got a question like this, wouldn't you be expected to simplify it? Right. All things should be simplified as much as conceivably possible. And that's pretty much as far as I have time for. So will you make sure that you've said your last name?